Okay, so Jill and I have now introduced a delay of just sort of a millisecond past the update rate of the position encoder, and we have a derivative controller value of zero point 0.4 and a proportional controller value of also zero point 0.4. And so what we sort of expected to see in this case was we expected to see sort of a change back to the steady state error that was a lot more kind of quantized and jumpy, but we figured it would be a bit different than what we observed when we had the position changing at a much slower rate than the Arduino code was looping, because we're never going to have the case where the derivative is zero, but the magnitude of the error is not zero. So in this case, we expected to see basically like less of this kind of up and down motion that we saw when we just had the the other case where the error could be the derivative of the error could be zero. So in this case, the proportional and the derivative controller are always both acting. So we don't see as much of that oscillation, which seemed to result from just the proportional controller basically getting to have some sway without the compensatory action of the derivative controller. So yeah, our idea seems to be more or less consistent with the data. We just look at some spiky oscillationness, which, I mean, I suppose that that could attribute just maybe some of the values that we have chosen for the proportional and derivative controllers, so we can experiment with that too. But yeah, so that's interesting. Okay, cool.